Resizable plugin interfaces and text. This is what this video is going to be about. Together with me on the screen, you currently see 3 of the most beautiful plugins that I ever made so far. The reason for that is because these plugins show you different stages of my journey of figuring out text in the context of resizability. All of these plugins are resizable fully. They do not require you to keep the aspect ratio. And all of these plugins have text in them. Let's start with Null Orbit, the one down here. So it is resizable. Let's make it really small. And you can see the text has the size that it just has. And when I make the interface bigger, then the text still has the same size. This is a very naive approach. It's just a fixed text size that is independent of the size of the window, and sometimes it looks a little bit silly, like now the text is definitely a little bit too small. I would say it definitely looks best when you make the interface rather small, but then you cannot enjoy the star field that looks so mesmerizing. So that's kind of sad, but it was one of my earlier attempts at making text rendering in a resizable window. So at some point I actually figured out how to make the text scale along with the size of the interface. So as you can see, when I make my plugin really big, then the text is also really big, and when I make the plugin smaller, then the text also gets smaller, which is pretty nice. However, what's not so nice is that every single label that you can see here in the plugin has its own text size. So every label just tries to make the text as big as possible, but completely in disregard of all of the other labels in the plugin. And that's why the plugin interface has kind of a chaotic feel. I even once saw someone describing it as psychotic in the comment section of some article that shared my plugin. I found that quite amusing, but I also see that this is definitely improvable. The same problem is in the plugin Manta, even though here it looks slightly better, I think. I kinda came up with a layout where it's just not too obvious, but it's still the same problem here. None of these texts are grouped together to have the same size. So now I'm going to show you something that is definitely way less spectacular, but it solves the problem. In my new plugin template, here you can see 2 labels. For now, just ignore the tooltip bar. It doesn't work the way I want it to yet. But just look at these 2 labels while I resize the interface. And you can see these labels, they have the bounds of the rectangle that they are in. And the second text never gets bigger than the first text can be in order to have a more consistent text size. However, both texts together are always as big as they can, depending on the worst case scenario, which is this block here with a rather long name Beats Basteln in a rather small rectangle. And in this video, I'm going to show you the methods that I created to make this work. Let's say you have a component of a certain size, and now let's say you have a text of a certain different size. So whatever is in here, it could be a multi-line of text and it has a certain size. And the first question is, how do you find out what's the size of your text? So this is the method. I called it bounds of because it's the bounds of a text with a certain font. Font also holds the information of the size of the font. So this is all you need to get the bounds. And I decided to return it as a point instead of as a rectangle because we only need width and height. We don't need X and Y. Okay, so I just defined a value called max string width as 0. Because if you look at this text, the first line is not very long, but most of the lines are very long. And the lines that are not so long don't matter for the width of the whole block of text. The only thing that matters is the longest line in the text. So if you know what the longest line of the text is, then you already know the width of the rectangle. And then the second thing is the height. Okay, so you need to find out how many lines there are. I defined a variable called sindex as the start index, and then I start from the next index after the start index, which is index 1, and then I loop through the entire text. And whenever the text reaches a character that describes a line break, then I get the width of the substring of the text from the start index to this index with this convenient method getStringWidth float. So this gets the width in pixels. If it is bigger than the maximum string width, then the maximum string width is now the line width. After parsing the entire text like this, you do this one last time just in case that after the last line break there is still text, which is pretty likely. And then you just get the font height of the font and multiply it with the number of lines. Font height is the height of each of the lines. So multiplying it with all of the lines gives you the whole height. And at this point you have the width and the height of the text and therefore the bounds, so you can return it. So the next question is, how would you have to change the current font size to make this text fit perfectly into this rectangle? In order to do that, you have to consider that this rectangle has a width and a height, and this rectangle has a width and a height as well. And if you get the ratio between these heights, these are supposed to be divide operators, then you have two ratios that describe how far away the dimensions are from each other. You can see this here described in my code, but I'm only getting the ratio that is smaller of the two of these because one of them is higher, and if you take the one that is higher, then it will exceed the bounds. If you take the one that is lower, then you always get something that fits. For example, if you squish this a lot, then this text cannot use all of the height all of the time because the width is too small. However, if you stretch it out a lot, then it cannot use the entire width because the height is too small. So that's why you have to use the ratio that is smaller. And then you just have to take the old height of your font and multiply it with the ratio to get the new height. In the plugin templates that I write, I always like to reinvent the wheel. So I also made my own label class to avoid having to use the one of Juice for some conveniences that I like. One of these is that I added the getMaxHeight function, which basically just gets the width and the height of the label and then applies the findMaxHeight function that you just saw to it in order to find out what's the maximum height of the current label text. So the next step was to think to myself, what if I have an array of labels as seen here in the arguments of this free function, and this function finds out which is the maximum common height, which is the function that you can see in the plugin as well, where it just finds a compromise between all of the labels, in this case just two labels. So you're looping through the labels and just find the maximum height that still works for all of the labels. And I made a little function that's basically almost the same, but instead of just returning the float, it immediately assigns it to the labels in question, just to have a little bit of an easier time later in the resized methods. And now here in the editor, we see the array of labels with the convenient enum ktitle and kdev and knum labels in order to give this array its size automatically. And that's pretty cool to use in the resized method, because now you can just say set max common height to this array of labels and boom, it works. I know a lot of developers avoid making fully resizable plugin interfaces because it just comes with problems like this, and then you have to spend time to figure it out, or else it will look a little bit janky. But I find these geometric problems very interesting, and they feel extremely satisfying to me when I finally solve them, like now. Yeah, texts in resizable interfaces, now a solved problem. A problem of the past, I hope.